We will only be doing one day of section 8.2, which is called the transformations of logarithmic graphs. And the reason is, at this point, we are so proficient at doing all of the transformations that really one day is more than enough, because we can see the basic things that we can do to these graphs. Now, when we take a look at the standard form, the most formal definition of a log equation, there's many things where you're like, yeah, you're right. We've done this many times before. The letters A, B, H, and K have not changed. Don't forget, C is not a new addition. This is not some new transformation of a graph. This is just whatever the base is of the log, and we'll address that as we go through. So what do these things mean? Let's go in reverse order. The plus K was a vertical shift, up or down, a vertical translation. The H, that was a horizontal shift, a horizontal translation, could be called even a phase shift. That was the old wall and window. The B was a horizontal stretch or compression, and the A was a vertical stretch or compression. Now, the same things happen where we're going to do our best to graph these. The A and the B we have to take a little bit with a grain of salt, although negatives can be brought in and they do the reflections. Now, how do we begin? What we have to do is we have to pound in that you need to memorize the basic log graph. So every log graph without any of the transformations follows the same shape. It crosses through at 1. The axis here acts like a vertical asymptote. It is a vertical asymptote, so this never ever touches or crosses the vertical asymptote. It just approaches it. And this can be any base you want. When nothing is written right here, well, it's assumed to be a 10. We could put a 2 there. It could be a 4. It could even be an E. And if it was an E, then we would change it to natural log x. That's how important that one is. So how do we go through the analyzing? What we'll do is we'll just do a few things at a time, or even just one thing at a time, and sketch graphs and also state some of the key aspects. So the very first one we're going to do is the equation y equals log with a base of 4, a subscript, and then x, and then a plus 3. So what we do is we don't panic. We acknowledge the 3 is in the k position. That is going to be a vertical shift. Now this is a little bit awkward to show. Normally, we would go through a value of 1, just like we've shown up here. That's a value of 1. What we are going to do is just go up, take a spot up here and put a 1. That's like taking this red dot and moving it up 3 positions. So then what would the graph look like? It really does follow the same shape, kind of tough to do by hand, but we have taken this graph and moved it up 3 places. Now, what stays the same? The domain of both of these guys is x is greater than 0, not equal to, again, because that's an asymptote. The range is all real numbers. It goes forever down, and it does not level flat. It keeps going up and over, up and over, up and over, even though it's more gradual. The asymptote equation is at x is equal to 0. On the x-axis, we're at 0. And then the x-intercept. What I'm going to do, even though in the PDF notes I wrote down y-intercept, because the y-intercept is an obvious answer. There is none. The x-intercept was 1 before we did any shifts. This one would be a decimal. So I'm going to write down the word decimal. I know that's not in the PDF notes. You would use technology, a graphic calculator, to figure out what that is. And so you've just seen your first shift when we put a plus 3 down. Now, our next equation, we're going to do another one of our shifts, and we can change the game up a little bit. Our next equation is y is equal to a log with a base of 9, and then an x plus a 4. So how do you analyze equations? I'm sorry I forgot the letters down. This is 2b now. So what we need to do is, first of all, acknowledge what is this shift. Well, this shift is in the H position. It is opposite what your brain is trying to tell you. Your brain might be trying to shift it to the positive because you see this plus, but it goes opposite. Now, how would you do this? There's really 2 key things that you'd shift. It's a little bit different than letter A. Now, normally what we had was we had an asymptote right here. The asymptote moves 2. So what I'm going to do is I'm going to go 1, 2, 3, 4, and I'm going to move the vertical asymptote over, and it's going to be at a value of 4. Everything gets shifted 4 in the direction that we know, so this here is a little bit of a change. This would go to a 4. Now, we had a y-intercept right here, an x-intercept of 1, and then the normal graph goes through. Well, that gets moved over 4 too. So 1, 2, 3, 4, and now I can draw the shape. I follow the general shape, and now I have this graph done. But we have to make a couple of other changes. The domain is not x is greater than 0 now. It is x is greater than 4. Not equal, because it never touches the asymptote. Our range is fine. Our x-intercept is not a decimal anymore. It is a perfect -3. And I don't think we should try to find the y-intercept. Again, that would require technology. And with a little bit of practice, you do see those. Now, for the next one, well, actually the next two, our final two, I'll just prep myself here. We're going to deal with, well, what happens with negatives? So our equation that we're going to look at for letter C is y is equal to, and just watch where the negative goes, negative, then log, and then a 4, and then an x. Now, you again have to recognize this negative, yeah, it's in the A position, but what does it do? Well, it does a reflection, and you really have two choices. Does it reflect over the x-axis, or does it reflect over the y-axis? And it's never changed. Okay, this has always been the case that the negative out in front in the A position flicks over the x-axis. So take this original graph that you memorized. That's the last of my, I demand you memorize them, flip it upside down. And now we have our general shape. What would this domain be? Well, it goes back to the original. X is greater than 0. The range, it goes forever up and it does go forever down, so YER, the asymptote is still 0. Hey, the x-intercept is still a 1. What would be the only thing that you could say differently? And this is coming your way if you take a calculus course. This graph working left to right is called increasing, and this one is called decreasing. You might be like, wow, whatever, but it is actually a very, very important idea. So don't brush it off too quick, even though we don't deal with it a lot in this course. Now, our final example puts the negative in the B position. Okay, so it'll be in here. And I just want to state again as I'm getting myself prepped. What I will not do in logarithmic transformations is actually do a lot in the A and the B. Imagine again, you put a number in front, like a 40. Well, it's supposed to make this 40 times bigger. Well, it already goes down to negative infinity and up to positive infinity. Yes, it does some subtle changes. Technology could show it probably quite nice, but that's not something that I'm going to test you on. What I will do is test you on the obviouses, the H's and K's, and then the negatives in the A and the B position. So for our final example, we have y equals log, then a base of 3, and what I'm going to do is put the x down. Don't get confused with these brackets. This is just to show that it's not a subtract x. Now we're going to put a negative in this spot. Now what it simply does is it takes this original graph and it flips it over the y-axis. And so once you see it drawn, it is really not that hard to imagine. It simply goes backwards. Let me start where I left off with example C. When you have this graph, if you're going to work left to right, you'd call this a decreasing graph. Now let's start to say, well, what's good and what's not so good? Is the domain x is greater than 0? No, it's actually x is less than 0 because it's everything on this side. And we do approach the asymptote even though I have a little bit too much of a gap here. The range, we're good to go. The asymptote is still a value of 0, but the x-intercept this time would be a -1. And so again, why do we only do one day of section 8.2? You guys are very, very proficient at these movements already. We just need to memorize what does the basic graph look like, and then we can do anything we need.